but it's not really a game, is it? Just crawling in and out of cupboards. So instead, we're going to add a monster today. But before we do that, we need a better way to interact with our game, because at the moment, if we go into my server script service, into our server script, we just generate a bunch of rooms and then that's it. We're not really reacting to the game environment. We don't know which room the players are in, for instance. So let's go ahead and we're going to use a bindable event. We're going to pop this into the room and we're going to add in a new bindable event. You might notice all the icons have changed. They look a little bit different, can be a bit confusing, but hopefully we can keep track of things. So we're going to name this bindable event player enter. Okay, and we're going to fire this whenever a player moves through a door, whenever they open a door, so we can know where they are. So inside of our door module, we can create a variable for that. Local player enter equals script dot parent dot player enter, and then whenever they open the door, we're going to fire that event. So player enter, and we say fire. Now we actually want to send a bit of data as well. I want to send not just the model that we've opened, but the actual number as well. So what we're going to do is we've already got the number inside door.new function. So copy this number and make sure we send it whenever we call this function. So here and here, we'll send the door model and the number. There we go. And then now we can make sure we are expecting the number. And then when we fire, we will send the number. And then inside of our main server script, we generate all these rooms, but we're not keeping track of where they are in relation to each other. So we're going to create a new table called local generated rooms, which is just going to be a blank table initially. Well, in fact, we could put the previous room as the first value. Okay, so that start room is going to be the first value. But then after that, we're going to add, every time we loop through this, we'll say generated rooms I. The value of I, of course, is going to be 2 initially, then 3 and 4 and 5 all the way to 100. And we're going to set that equal to whatever the new value of previous room is. And so once we've gone through and generated everything, we should have a nice little table, which will show us the order of all the rooms. So if we just do that and if we click run, we should get in the output. Let's see, we have a table. And if I open this up, we can see we have a nice long table, 100 long. Starts off with the start room, then left snake, upstairs, left turn, and so on, which is the exact order everything is in. Left snake, upstairs, and left turn, and so on and so on. So now we have this nice little table. Let's make sure we're actually receiving when a player enters a door now. So we fired off that event. Let's receive it here on the server script. So we'll create another variable, local player enter equals script dot room dot player enter, and then down here at the bottom we can say player enter dot event. So when that event is fired, we're going to connect that to a function, and we'll take the number as a parameter. And now we can make things happen when the player starts to go through certain doors. So for example, we could say if number equals 3, then let's just say workspace clear all children. Okay, so we're going to delete everything, but just as a quick little test. So if I was to click play now, we can load in and join the game. Here we go. So we go through the first door, no problem. 1, 2, and when we go through the third door, things aren't going to go very well for us. We go through here, and oh gosh, everything has been deleted. And it's going to cause a few glitches because the game doesn't really like us trying to destroy everything, such as the terrain, and it breaks our character a little bit. We would have to reset, I think, to get that to work. Maybe it's all broken, but anyway, we can see that it's working on door number 3. But we don't want to just delete everything. Instead, we want to spawn in a monster. So let's go ahead and create our monster. So to do this, I'm going to actually take a copy of these door templates. So we see we've got one here, entrance. I'm going to copy that, move it into the workspace, and just move it out of the way. Okay, so I'm going to rename, let's rename it from entrance to skull. And then on this side of it, I want to add in a image. So I'm already got an image. I'm just going to paste that on top. There we go. We've got a spooky skull. And then I'm going to want some sort of smoky particles around him as well. So I'm going to duplicate the skull. And then I'm going to resize him. Okay. And I want this wide part to be as wide as the widest corridor. So obviously these aren't that wide, but I have got this gallery, which is really wide. So I think I need it to be probably 50 studs or so wide. So make it really wide like that. Perfect. We'll rename it from skull just to smoke. And then we're going to unanchor this part, unanchor the smoke. We can delete the decal, and then I'll add in some particle effects. So use a particle emitter, and then we can have some lovely little twinkly effects. It's not going to have quite the bone-chilling effect we're looking for, but I have already made some effects. So I'm going to delete this and place in new effects next time. And let's make sure both of these parts are fully transparent. There we go. And I think we have something that looks a little bit more spooky. So let's take the skull and we'll click the smoke, and we're going to weld these together. So we'll create a weld between them both. There we go. We can see that weld constraint has appeared. And then we're going to select them both and Control-G, group them together. We'll call this guy skull or shadow or something. Shadow, I guess that works. And then we'll create a new folder to put them inside. We'll keep everything organized. Since we've already got furniture, item, and a room folder, we'll create a enemy folder, and we'll drag this guy inside of there. There we go. And then we're going to create a new module script specially for him. So we'll add a new module script into the server, and we'll call it shadow. We could obviously call this whatever we like. It's called Rush in the actual Doors game, but we'll go with Shadow just to be a bit different. So we'll rename it to Shadow, and then we'll have a function shadow.new. And what we're going to expect for this is we're going to need a place to spawn him into the world. And to do that, we're going to use that very table that we just created, right? That generated rooms table. So we're going to want the number that we're currently at and the total table of everything, the generated rooms. So we'll start by making a copy of him. So local enemy model equals workspace dot enemy, that folder we just created. Maybe it should be enemies, just as soon as we've got everything else to be plural. Sure, we'll do enemies. There we go. Workspace dot enemies dot shadow, and we'll create a clone, a copy of him. And then what we want to do is when a player moves through any of these doors, we don't want to spawn the monster immediately at that very door that they've just walked through. Otherwise, they're going to get killed rather quickly. Instead, we want to generate them a room or two behind and then have them move through the world, maybe an extra room in front as well. So the first thing we're going to do is work out what the previous number is. So the previous room number is simply going to be whatever the number we've been given, that minus 1. Pretty straightforward. And then local max num, that will be, let's just make these num, is going to be however far forward we want to go. In this case, maybe we'll just do it an extra 1 room, okay? And so then we can work out these values. So the maximum room and the previous room itself. So the room model, the previous room model, is going to be equal to the generated rooms table and then we'll just use that previous num value. And then we need to work out the maximum room. Now, we can't simply do this because it's possible, say, if we were on the 99th room, we could actually go one too far. So let's just check. If not generated rooms max num, if for some reason it doesn't exist, then we can say that the max num will simply equal however many items there are in the table. So hashtag generated rooms. And so now we know that the local, the max room is simply equal to generated rooms max number. Okay, so then what we want to do is we want to place that enemy into the position of the previous room. So we can say enemy model, and we use the pivot to function, and the position is the previous room dot the entrance part dot cframe. And then let's make sure to give him a parent. So enemy model dot parent, and it'll place him directly into the workspace. So that's our shadow module script done. Then in our server script, we're going to need to require that. So where we've got all these other modules, we can say local shadow equals require script dot shadow. And then inside our player enter event, if they enter door number 3, then shadow.new, we give them the current number and the table of all the rooms. And we don't need to print them out anymore. So we can remove that line. Okay, let's hit play and we can see If this has worked for us. So we can move into room 1. Oh, look, we've got the gallery straight away. Wow, what are the chances? And if we move into room 2 and then room number 3, And if we look behind us, we should now see there he is. It is the spooky skull himself. So he spawned 2 rooms back. Well, 1 room back, but of course, because of how it works, he's gone 2 rooms back right to the start room door. There he is. So, through the levels, it's not stop. What we're going to want to do is we're going to want to move him, and how we're going to do that is we're going to use something called lerp. But before we do that, we're going to need some sort of waypoints to move through the world with. Now, obviously, if it's a straight room like the gallery or any of these corridors, well, we can simply tell him to move from the entrance part all the way to the exit part. It's a straight line. That's pretty straightforward. But if we've got one of these, say a corner especially, but also those stairs, if it's a corner, well, we can't just tell him to go from this one to this one because he'll travel in a straight line like that and it'll cut off the corner and it will just look terrible, frankly. So what we're going to do, you'll see I've actually already created some little waypoints here myself. What we're going to do is we'll take the entrance part. And we're going to duplicate it like so. Move it forwards to just before the turn. So like here. And then we're going to name it 1. And we'll make it fully transparent. And then we duplicate it again, move it forwards, rotate it. Rotate it 90 degrees, and then we'll move it round to the next corner. There we go. Make sure it's all lined up in the center. And then we'll name this one 2. Then we'd move it forwards again, right before the next corner. We would name this one 3. Duplicate it one more time. Rotate it again. Move it right round the corner. Make sure it's lined up. Is that lined up? We need a half stud to the left. Like so. There we go. It's lined up now with the exit. And then we name this one 4. And so once you've got all of these waypoints, you could select them all like so. 1, 2, 3, and 4. Add them into a folder and name them waypoints, which you see I've actually already done. I already had another set here. So now I've got 2 sets. I'll delete one of these. But there you go. So we've got our waypoints, and we need to have this for every single room. So every time you've got a corner like that, you're going to need to create some waypoints. You see I've got some here. There we go, exactly the same for the other corner. And I've got some for the my little snaky one as well. If I can find it, there we go. Some more waypoints here. We've just got 2 waypoints here. It's just one corner. But for the long corridor, say, for example, I haven't actually got any waypoints at all, just the entrance and exit. So you only need to add the waypoints if you've got a corner. I did go ahead and add some for the staircase as well. You'll see I've got a waypoint here, one at the start of the staircase and one at the bottom. And just as with the entrance and exit parts, it's really important that you have the orientation indicator correct. So I have all of mine facing this way. So we can see when we look at these waypoint parts, they're all facing exactly the same way as the door. So everything lines up all the time. If you swap the orientation indicator around, then it's going to cause some problems for our enemy moving through them. But once you've hopefully gone and created all of your waypoints, we can now go and start programming that. So let's head back into our shadow module script. And we're going to create a new function called shadow.navigate. And so we're going to need the model to move. And then we're going to have the previous num and the max num. So these start and end rooms to move through. And we'll need that table of generated rooms again. And so we're going to have a for loop. So for I equals previous num and finishing at max num do, and then we can get the room. So the local room is simply going to be equal to generated rooms I, and then we can tell him to move to any of these rooms. So like I say, we're not using a humanoid here, so we can't say humanoid move to or anything like that. We're going to use lerp. So we'll create our function for that. Function shadow.lerp2. And this is going to simply have the model and the target we want to move towards. Now, if you're not very familiar with lerping, I'm probably going to make another standalone video on this at some point. But lerping is essentially about interpolating between different values. So if we have one value A that's equal to 1 and one value B that's equal to 10, and you wanted to create a value C that was halfway between them both, well, that would be 5, wouldn't it? That would be 50% of the way. Now, in our case, you want to keep generating whatever fraction of the way we want to move inside a really fast moving loop to allow him to move smoothly through. Now, this fraction is known as alpha. So we set the alpha initially equal to 0. Then we're going to set a speed that we want him to move at. I'm going to set this to 50. And then we're going to say that the local distance is equal to the model.primary part.position minus that target.position. And then we're going to get the magnitude of this. So the total distance, right, dot magnitude. And then from this, we can calculate a relative speed. So the relative speed is going to take into account the distance. So that's simply equal to distance over speed. And now we're going to need to actually keep track of his starting position. Because if we're moving him, then we need to know where he started off at. So his start C frame will be equal to the model.primary part.C frame, and then we'll create our loop. So local loop will be nil initially, and then we'll set the loop to, rather than just using a for loop, we're going to use something called run service. So run service allows us to tie things on a frame by frame basis, so we can have a really fast running loop. So get service, run service, and then we'll say loop equals run service dot heartbeat, so we can see it fires every frame after the physics simulation has completed. So whenever the heartbeat fires, we're going to connect that into a function, which gives us a really tight running loop. And we can see one of the parameters is something called delta. Now, delta tells us the amount of time difference between each frame, which is going to be very useful. So the first thing we want to do is we want to work out how far we want to move. So local goal C frame is going to be equal to we take the start C frame, and then we're going to lerp. And we want to lerp between the two values there's two values. The first value is the start C frame, and the second value is our target, which we have as a parameter for the function itself. And then the second thing we need to say is the fraction of the distance we want to move. Now, in this case, it's going to be alpha. Now, initially, that's 0, which is fine. On the first frame, we want it to be at the 0 position. And so we'll say model pivot to, and we'll pivot it towards that goal C frame. But after we've done that, we need to calculate what the next value of alpha is going to be. So alpha plus equals, so we want to add to it, and that's going to be that delta value. Okay, so that's how long since the last frame. It's normally about 0.1 of a second. So that divided by that relative speed value. And then finally, we want to say if alpha is greater than or equal to 1, then in that case, we have finished the loop. So we can say loop disconnect. Oh, there we go, disconnect. Now, this was going to move us to only a single position, and we want to move to multiple positions. So that's why I created this for loop down here in the navigate function. So what we're going to do now is we can call that lerp2 function. So shadow.lerp2. We want to go from the model and want to move it to the room.entrance. And then we're going to need to see if it has any waypoints, any of those waypoints that we just created in those folders. So let's check if it has a waypoints folder. Local waypoints equals room, and we'll use the find first child function and look for something called waypoints. Now, if it does have waypoints, then we're going to want to loop through them. So we'll create yet another loop for I equals 1 and the number of waypoints. So that's hashtag. Hashtag gives you the amount of items in a table, and that table is going to be all of the children elements of the waypoints folder. And so what we're going to do is we're just going to use that lerp to function again, and we're going to lerp to each of those waypoints. So we send the model, and we want to move to waypoints and the I value of the table, which we're getting from the loop. Now, there's one problem with this so far, which is that when we are running this, well, we haven't added any sort of weights. We haven't added a task dot wait to pause in between. We're just sort of doing everything all at once. And how could we know when this loop has finished, when we've disconnected? Well, one way of doing this is to use yet another bindable event. So I'm going to go down here and I'm going to say local reached target and make that equal to a new bindable event. And so now when we disconnect from the loop, I can fire off that event, fire. And at the end of the function, I can say reach target dot event, and I can wait for that event to fire before we actually return the function, before we finish it. So it's going to keep yielding. It's going to keep waiting here until this loop is finished. So that will add in a wait, and it can be dynamic rather than having a set time that we actually type in. So once we've done that, and once we've finished moving through all of these, we need to move to the exit. So shadow lerp to model room dot exit. There we go. And then this is going to keep repeating through each of the rooms you want to move it towards. So we set it to -1 and +1, but obviously we could change these values if we wanted. But once we've done all of that, we're just going to destroy the model. So enemy model. Oh, we haven't even called the function. Look. Have we? So we're going to want to call that function. So shadow dot navigate, and we're going to need to send the enemy model, the previous number, the max number, and the generated rooms. And then we know that once it's done, we can safely destroy that model. So that's a lot of scripting. Hopefully you've stayed with me. But now let's go ahead and play. See if we got any errors. Make sure our output window is open. We'll hit play for ourselves. Let's see. If we go through the third room, and oh, we have got an error. Look, attempt to index nil with position. So what's going on there? Let's hit stop, and we go and look at line number 7. So I'm guessing there's probably a issue with our target. Let's just check. So when we're calling the lerp to room.entrance waypoints I room.exit, that looks okay. Has our model got a primary part? Let's check. It hasn't got a primary part. So let's click the shadow primary part and we'll set it to the skull. Okay, so now we've got a primary part. Things should be looking up. We'll clear this output. We'll click play. And then we'll come around the corner into the third. Third room, and we've got another error, so we have to go back. And we'll check on line number 14, enable cast instance to coordinate frame. And we just forgot to set the C frame there, didn't we? So target dot C frame, because target is just the instance. Right, let's try. One more time, guys. There we go. 1 and 2 and number 3. There we go. And if we see, whoop, there's the the little monster there.